There we go. All recording. So, welcome everybody. Thank you very much for joining C2C webinar. We have been doing that now since COVID-19 happened. Sadly, we cannot do something physically and together in the same room. However, Zoom help us to set that up. And thank you very much, Nichola, for being joining us at Crush to Cellar for talking about nutrients. Harvest is around the corner and started in California and some areas around us here in Oregon as well. So first, Nichola, can you introduce yourself?
Of course I can. Thank you, Sebastian. So to those of you who know me, hello. To those of you who don't, my name is Nichola Hall. As you hear my accent, I'm not from the US. I'm actually from Scotland, where I was born and lived until I was about 25. I have an undergraduate degree in microbial biotechnology and a PhD in yeast physiology, which was what actually brought me into the wine industry, with my first position being Director of Microbiology at Bronco Wine Company. I've been with Scott Labs now 11 years.
Well, thank you. First, with COVID-19, I like to give a little bit more human feel, and I would like you to describe where you are and describe your surrounding.
Okay, today I'd much rather be a robot than human. Pretty crazy here right now. So working from home, been working from home since March. Home is Santa Rosa in Sonoma County. So those of you staying abreast of the news, we had some horrible lightning strikes about 10 days ago now, which sparked huge wildfires. We're pretty safe right now at home. A lot of friends were evacuating back home, and we're just starting to get back to normal, whatever that is. So Santa Rosa is where we are. It's pretty foggy this morning. We've got that good marine layer that's come in that's really helping us with our temperature and our wildfires.
Thank you. Yes, it's terrible. I was in California when that night started. We drove, my wife and I, for 10 days vacation there, and we stay in the Berkeley area. It was Saturday night when everything started, lighting around us. So we know then Harvest 2020 will be different at that point. I just drove back a few days ago from Berkeley and drove to Oregon. And to be honest with you, from Berkeley to maybe 20 miles in Oregon, we only saw smoke and did not see any blue sky. So it's not just in a Napa area, but it's all over. So it's very sad to see that. So stay strong, winemakers there. And a lot of smoke tent webinar, I'm sure, will happen, and some already happened. We know that it's not much we can do, but Nichola can also help you with some ideas of how to handle this situation when you have smoke tent in your grapes, and what to do or not to do, or what to do to reduce at least the issue. So that is another subject, another topic. However, good wine is made with good grapes, and that is number one tool to be able to produce good wine, but also with healthy fermentation. And with this healthy fermentation, yeast need to have good nutrients to be able to ferment well. So in general, what nutrient do yeast need, Nichola?
Absolutely. So if you think about yeast, they're eukaryotic organisms, which are the same as what we are. So in general, yeast need carbon, nitrogen, oxygen, sterols, minerals, and vitamins. And they all have different roles that they play in a successful fermentation. Utilizes all of those different nutritional factors, and the yeast uses them in different ways. The winemaker generally focuses on nitrogen. It's something that we can measure. It's something that we have learned how to adapt to. But we are starting to learn, Sebastian, that nitrogen is not actually the most important nutrient for yeast. It is the nutrient that drives cell number, it drives fermentation rate, but having too much nitrogen is actually more of a problem than not having enough. Not having enough we can control. Having way too much means that our cell population is too great, and then we need all of those supplemental nutrients to support the high biomass. So in general, carbon, nitrogen, sterols, oxygen, vitamins, and minerals.
So DAP is not the only tool we have.
DAP is a nitrogen source, not a nutrient source, and they're very different. We have, as an industry, used them interchangeably, but we're working to change that.
Okay, what does yeast need during its different growth of stage?
Oh, okay. So the yeast, when we get them in an active dried form, they're about 8% water. So that's removing all the cellular water has allowed them to shut down their metabolism. Yeast have about 6,000 genes. And when we add them into rehydration water, it's a very dynamic process. And we've got about 3,000 different genes that are being activated. But we don't really see any of that activity, any of that action during what we call the yeast lag phase. And that's the time between introducing yeast into the juice or must and 2 to 3 Brix drop. So we don't see much sugar depletion, but during that time, the yeast need a lot of vitamins. They need the minerals in order to produce the enzymes to consume all the sugar. During that time, they're also going to use nitrogen. About 1/3 of the nitrogen is depleted during the yeast lag phase, so that 2 to 3 Brix drop. Once they come out that lag phase, they're going to go into their exponential growth phase. And that's when we see the maximum rate of fermentation. And it's during that time that they really need nitrogen. After you hit your peak of fermentation, which is generally about 1/3 of the way through, the cells are going to go into a stationary phase. So that means they're not going to be growing anymore. They need a little bit nitrogen again at that stage in order to continue with sugar uptake. And it's during that stationary phase that they also need nice, strong, healthy membranes. And in order to have nice, healthy membranes, you give them oxygen to produce the sterol. So they need different things at different points.
Just quick additional question. Does they will work the same with any type of grape varieties, or you see different changes in response from the yeast at different grape varieties?
Pinot Noir ferments very, very fast. That one I think is a little bit harder to manage from a nutritional standpoint, just because of those very fast kinetics. But the yeast does not know it's in Pinot Noir. It doesn't know if it's in single vineyard Chardonnay. It doesn't know it's a Grand Cru, right? It knows it's in a high sugar environment that's very acidic at various temperatures with various nutrient sources. So the yeast need what the yeast needs, and that does not change too much based on variety.
Okay.
Now, what the varieties give the yeast will differ, but what the yeast needs don't change.
Okay. How do I know how much yen I need? How?
Yeah. So yan being yeast-assemble nitrogen, which is what we focused on because we can measure it. If we look at how much nitrogen it requires a yeast strain to consume 1 gram per liter of glucose at 24 degrees Celsius, we will see that yeast, all of the different enological yeast, so not just the yeast from Scott Labs, but all of the yeast within your portfolio, Sebastian, will follow generally the same rule, that they will require to consume 1 gram of sugar, 0.5 parts nitrogen, all the way up to 1.5 parts nitrogen. So we look at the response and we'll say, well, you guys are all low nitrogen requiring strains. This group fits into what we call medium nitrogen requiring and then high nitrogen requiring. So we'll say the yeasts that are low nitrogen requiring, for every gram per liter of sugar the yeast has to consume, they need about 3/4 of a part of nitrogen. If it's a medium nitrogen requiring strain, for every gram per liter of sugar, they need about 0.9 parts nitrogen. And if it's a high nitrogen requiring, for every gram per liter of sugar, they need 1.25 parts nitrogen. So a 25 brix can vary between 190 parts nitrogen to over 300 parts.
Oh.
So that's a number that you can really adapt to. You're going to know what your original YAN is because you're going to measure as close to yeast inoculation as possible. You'll see what that number is. You can calculate what you need based on your yeast requirements in that sugar, and you look at the difference and you adapt for the difference.
Okay, so important to run the YAN, send your sample to ETS, or do your YAN correctly, start with a very accurate number because it's the key of a healthy fermentation here. So what happens if I add too little or too much, nitrogen?
If you add, so if the fruit is healthy, the minimum amount of nitrogen you require is about 150 parts per million. So if you don't supplement, or if you add too little and you don't reach that bare minimum, you will just have a long fermentation, a long, slow fermentation. That the yeast may not have what they need to finish out that last little bit. So you might tail off with a couple of grams per liter sugar left. If you add excessive amounts of nitrogen, the yeast is going to take it up very, very quickly. Which means they will grow quicker, which means you'll have a faster fermentation rate and higher temperatures. So you might be struggling to keep things under control. So instead of you, the winemaker, being in control, it is the yeast that is in control. So it's just a much more challenging situation. If your original YAN comes in high, you want to choose a high nitrogen requiring yeast strain. And that's a nice match. If your nitrogen comes in low, you'll want to choose something that's a low to a medium so that you can compensate for that deficiency sensibly. Does that make sense?
Yes, absolutely. And sometimes as a winemaker, you produce wine and then your fermentation kind of slow down at the end and you're like tempted to add a little bit more or not, but you're always afraid to add and it's not consumed to the wine. What is the risk to add nutrients at the last phase of a fermentation and you maybe add nitrogen in your wine that will not be consumed by the yeast? What is the risk of that? So
we throw the phase out nutrient desert. Like we want our wine to be a nutrient desert. And I like to call BS on that from a microbiological perspective. It's like hello aging on lees. Mm-hmm. The way the yeast, they're going to take up the ammonia first, very, very quickly, because that is a preferred nutrient source for them. They don't have to work very hard to get the nitrogen off the ammonia group. They get rid of the hydrogens, thank you very much. They've got to work a lot harder to get the nitrogen from the primary amino acids, which is everything except for proline. So they take those up a little bit slower. They take them up in a preferential and consecutive manner, so that all the, what we call the AGs first, the alanine, glutamine, glutamate, then they'll take up others. Then lastly, they take up the aromatic amino acids, which are precursors for esters. However, if we're to follow the uptake of these compounds and the release of them, we'll see that actually at the tail end of fermentation, the amino acids are actually released back. And that is what makes some strains more ML friendly than others. So you're never going to really have a nutrient depleted situation. So that kind of addresses that part. The second part is that you were asking was, what about if something's slowing down at the tail end, can I add nutrients? Well, if you think it's slowing down because of a nutrient deficiency, possibly, but generally it's not. It's generally something else. A lot of winemakers don't like to mix their ferments. So as you have a lot of striations in fermentation. And if you don't keep your ferments mixed and a CO2 generation is slowing down, your yeast is actually going to settle out. So it's not actually, it doesn't have access to the sugar. So I'm mixing. If you absolutely have to add nutrients later on, the amino acids can be taken up late in the fermentation. Ammonia uptake is inhibited right around 10% alcohol, which is why I tell winemakers 8%, because 8% is going to be 10% soon by the time we get around to reacting. So yes, they will take up amino acids late. They will not take up 100% of the amino acids because their uptake capacity is diminished as the alcohol increases, but it is still possible. The uptake of ammonia we think is not possible because of the specific uptake systems that the yeast use. A very long answer for
no,
very short question.
Is all yen treated the same by the yeast?
No. So just like all nutrients are not treated the same by the human body, all nitrogen, yeast-soluble nitrogen, is treated differently by the yeast. We have what we call easily assimilated nutrients, and those are things that the yeast are going to go after first. Then, so as I mentioned, that's ammonia, glutamine, glutamate, alanine, arginine, asparagine. Then they'll take up, and those are all very rich nitrogen sources for the yeast, so that will produce a lot of biomass. Then they'll take up things that they call intermediate nitrogen sources. Lastly, they'll take up the more complex amino acids, and those are the branched chain or aromatic amino acids. Things like phenylalanine. So we talk about phenylalanine a lot as a precursor to floral notes or honey notes in wine. The isoleucine is another aromatic amino acid. So things will be taken up in a consecutive manner. So they absolutely do not treat each nitrogen source like we do. We give everything an equal, or we equalize everything. The yeast does not. And we can see that the yeast is, if you have a balance of amino acids there, the yeast are about 4 to 6. At Scott Labs, we're a little bit more conservative. We'll say 4. The yeast are about 4 times more efficient with amino acids compared to ammonia. So an amino acid rich nutrient doesn't bring much in the level of yan, but from a yeast efficiency standpoint, it actually allows the yeast to react like it's had a similar level of DAP, but without the heat spikes.
So I send a sample to the lab and I get less than 75 ppm of yan. Example, you know, how I deal with, you know, this low yan.
So 75, you're going to look at your sugar, and that is your fermentable sugar, so after any adjustments. And you would want to choose a low nitrogen requiring strain. You never want to have to add more than 150 parts yan. That is what we would say is an excessive addition. Now, and I'm going to have to use my calculator because my math isn't that amazing. So if I had a 25 bricks or 250 grams per liter fermentation, and I would use a low nitrogen requiring strain, that means that I need 187.5, so 190 parts nitrogen. I need to supplement to secure this fermentation using a low nitrogen requiring strain. If I had 75 parts, my supplementation is 112 parts. Because that is more than a 50 part per million add, you would want to split that add up into two phases. The first part would go in at 2 to 3 bricks drop so that the yeast has enough nitrogen to get through their active growth phase. And the second part at 1/3 sugar depletion as the cells are coming out of their active growth. And that second addition of nitrogen regenerates all the sugar uptake protein so fermentation can continue. So adding 115 parts yan is very manageable. It's it's below that 150 maximum that we would want to add.
Okay.
Make sense?
Yes, absolutely. It's clear, and that help a lot. It's practical answer. That I like that. You know, to help winemaker out there, it's very good to have some practical answer.
And remember, when you're doing your add, Sebastian, oxygen at the same time.
Okay.
When you're adding your nutrients, it's in a slurry. You don't add it dry. Once it gets added, it's with a good mix, because your yeast need about 5 to 10 parts oxygen, and a good pump over will give you about 5 to 6.
With
So,
oxygenation, so you put this like oxygen device, so try to bring some oxygen in the tank as you.
yeah.
Okay, so we talk about, you know, like, let's talk. You put that in a corner of the tank in one spot, or you put it in the one spot and wait a little bit time, and you do like your pump over with oxygenation overnight, or what do you do? What is the protocol here?
When you add your yeast, or when you add your nutrients, sorry. Or
When
we
you,
could address both.
yeah, both, you know, so you put your yeast, you put them in the corner of a tank. The day after you do your pump over, you start fermentation, you arrive to your 2 or 3 bricks drop. And at this point you put your nutrients. And when you add your nutrients, what is the protocol? You just mix in the wine and dump it on the top of the cap?
When you add your yeast, it needs to be mixed in. You have calculated your yeast based on your final volume, whatever that final volume is. When you first add, so yeast have different, and this might get a little sciencey nerdy, so stop me if you would like. Your yeast have different uptake systems. They've got uptake systems that are operational when you've got lots of nutrients, and they've got a different set of systems that are operational when you've got low nutrients. And the yeast are very dynamic, and they'll switch between what is operational depending on the environment. So when you put all your yeast in one little block at the top, they're going to initially sense a very nutrient-rich environment, but they're going to know there's a lot of cells. So they're going to take up a lot of nutrients, leaving that little block deficient. So they're going to switch their metabolism, and they're going to enter into a nutrient stress situation. Okay, and then the first time they see a stress, they're going to, oh, I don't like this. The second time they see a stress, they're going to, and they're really going to start to shut down. That second stress they'll see is ethanol. Okay, so we want to make sure when we add our yeast, we mix them in so they've got enough space for themselves, they've got enough nutrients for themselves, and they're starting to outcompete the other organisms that are in there through a concept that we call microbial crowding. So if you don't mix them, change the metabolism, you have higher acetic acid, you might have higher levels of pyruvate, which, remember, next to acetaldehyde is one of your highest SO2 binding components. So you're not making the healthiest decision.
Okay.
When you add your nutrients, okay, in a white, it may filter down eventually. In a red, it's going to get stuck there in the corner, especially 2 to 3 bricks when it's still a pretty solid mass. You're adding the nutrients, so you're nourishing your yeast. So take the nutrients to them, help them out. So once you add your nutrient in, make sure you mix it.
Okay. Okay, so we talked about low yen. Now let's talk about high yen. Okay, example, I have more than 300 ppm of yen, you know, after sending the sample to a lab, and how do I deal with that? What do I need to do with this 300 ppm?
So the high yen is harder to deal with. The yeast is going to take it up all very, very quickly. So the time it takes for you to get a third of the way through fermentation, high yen situations, is going to be much faster than in medium or low nitrogen situations. So you're going to get to a third of the way through really quickly. You're also going to have a much higher cell number. And some newer work out of INRA is shown that in high yen situations, when you don't have enough vitamins and minerals there, you have less viable cells, less vital cells. So your fermentation doesn't behave like you want it to. And it depends on what the vitamin is that is deficient, but you'll see a very sharp decline with regards to living cells. So high-end situations, you should always use your rehydration nutrients, because that's a way to get those vitamins and minerals into the cell in a non-competitive environment. And 1/3 of the way through, a small organic nitrogen addition, 10 to 20 parts per million, that will regenerate the sugar transport proteins and help with a cleaner end of fermentation. And then 300 yan, you're going to use a high nitrogen requiring yeast, right? Yeah. That is its niche.
Well, thank you. That is also very, very helpful. So why do we need to stage the nutrient add?
Because yeast need different things at different times. As they're growing, they need vitamins and minerals, they need nitrogen, and at 1/3 of the way through, they've run out of nitrogen, irrespective of what your nitrogen is to begin with. And that is a generalization, but that's what we generally see. So that if you don't re-add nitrogen at 1/3 of the way through, the way that sugar is taken up into cells, taken up through transport proteins, and nitrogen is used to regenerate the proteins.
Okay.
So if the cell runs out of nitrogen for about up to 72 hours at that point, you can't restart it through nitrogen addition.
Okay. So we didn't talk about reduction. I got one question about reduction. You know, how Pinot Noir can be you know, we talk about no prime finishing, but focus on limiting reduction in Pinot Noir. Any recommendation?
So volatile sulfur compounds, 4 sources, right? Elemental sulfur, SO2 more than 80 parts at crush, sulfate, and sulfur containing amino acids. Okay, so that's your sources of volatile sulfur compounds. Your yeast has different capacities to produce sulfides. One of the key components in managing sulfides is calcium pantothenate, which is a vitamin. If our calcium pantothenate is too low, and well, calcium pantothenate is a precursor for acetyl-CoA. So in the cell, if acetyl-CoA is too low, which is a central molecule in yeast metabolism, then you don't get the reduction of your sulfur-containing amino acids to the homoserine. What happens is it pumps out this excessive sulfur as H2S. So making sure that in your Pinot Noirs, because they come in at generally high yans, that you have enough of the vitamins there. You will also get sulfides produced through nitrogen depletion. So if your nitrogen is high to begin with, you generally see that the sulfides is due to calcium pantothenate deficiencies, assuming that you're not doing anything crazy like adding more than 80 parts SO2 at crush, or you're not spraying with elemental sulfur too close to harvest.
Okay.
Yeast stress as well, minimizing your yeast stress, so keeping things mixed and you're not compacting your cells.
So how do some nutrients impact aroma compound positively and negatively?
Okay, so we could split our aroma compounds up into impact molecules and compounds, or groups of compounds that help to form aroma. So impact compounds are things like varietal aromas, thiols and terpenes. The thiols are bound to an amino acid. If we have too much ammonia there, then we don't have the amino acid taken up because of that preferential uptake of the nitrogen sources. So the thiol, or the thiol conjugate, the thiol bound to the amino acids, is not taken up into the yeast, and the yeast is what reveals your thiol. So too much ammonia will inhibit thiol uptake and expression. Likewise, to stimulate the thiol expression, things like vitamins and sterols help. For esters, it's not, esters are fruity floral compounds that individually they don't contribute to aroma, but as a group of compounds, they're odor important compounds. So the precursors for esters are amino acids and sugar. Depends on if it's a fatty acid ester or an acetate ester, so ethyl ester or acetate ester. If it's an acetate ester, you need those amino acids there, those aromatic amino acids that the yeast take up and put through a series of biotransformations to get your floral note, your fruity note. So if you're not giving the yeast amino acids, if they don't have the precursors there, they can't produce them. The other thing with esters is your level of solids is very important, especially for white wines. So the clearer the juice, the higher the ester production. And that was some work also out of INRA. They're doing a lot of really cool stuff right now with regards to yeast nutrition and aromatic metabolism, how to stimulate the secondary metabolism. And they looked at 2 milligrams per liter of phytosterol, so those natural grape sterols. And 2 milligrams is about 60, so 60 NTU. They looked at 4, 6, and 8. So looking at ester production from 60 NTUs to 240 NTUs. And generally, when everything else is equal, the clearer the juice, the higher the fruity compounds that are produced by the yeast.
Oh.
So nutrition, but as well something really simple like solids management.
Okay, important. We've known Saccharomyces, now new player on the game. Do we need to change the protocol of nutrients, or does that have an impact in terms of procedure of nutrients protocol?
Yes, when we spoke about nutrition for years, we've always said now the non-sac are scavengers. They will scavenge your vitamins and minerals from, it's just been a common phrase, a solid understanding. Now we're adding in these non-Saccharomyces. So your vitamins and minerals can go from replete, so we've got enough there, to deficient in about 3 hours. The other thing is our non-Saccharomyces will use our nitrogen. They will use, some of them will use ammonia, others will use amino acids, depending on how much is there to begin with, what our starting yan is, will impact how much is used. So, for example, if you're starting at 300 yan, they might use 25%, but that's 75 parts. Whereas if you're down at, say, we were talking about 75 yan, they might use 80%, right? So that's leaving you starting a yan of 50. So it's using them sensibly. And when you measure your yan, you measure it after your non-sac has done its job.
Okay.
So sometimes in these high yan situations, using your non-Saccharomyces as a scavenger, as a way to clean up some of that nitrogen, might not be a bad way to go.
So that is good. That is important information here. So when we take the yan, when the grapes are in the tank, we add the non-sac, and recommendation now is after we let soak with non-sac during cold soaking, we take another sample and run again the yan. And at this point, we start with a good number for protocol, the addition nutrient.
Yes,
okay.
Exactly. Well, and that's just even if you are just doing a cold soak, your yan is yeast assembled nitrogen for Saccharomyces, right? We kind of forget that it's for Saccharomyces. So we want to adapt that number based on our conditions. So we want to run it as close to inoculation or even just after as possible. Remember, at the beginning of fermentation, what we call fermentation, you're not seeing any change in sugar. but you're seeing a huge change in these other yeast nutrient and yeast growth factors. So I think sometimes we think, oh, I don't see any change in sugar, so nothing's happening. It's the exact opposite. There is a lot happening. It's just, it's not evident to us in the analytes that we look at.
Okay, very practical. Thank you for that. Let's talk about legal consideration when it comes to nutrients. We know that we have some limit, you know, to not pass. Can you give us some information about the legal nutrients consideration?
Of course I can. So products don't get approved for use in winemaking. It's individual ingredients. Some nutrients are a single ingredient, like autolyzed yeast. Some nutrients are blends of autolyzed yeast and DAP. Other nutrients are blends of autolyzed yeast, DAP, yeast hulls, vitamins, and minerals. So you have to understand the blends of what you're using and where they fall in the regulations. So DAP on 24.246, which is the part of the CFR that was part of the reciprocal trade agreement in 2006. So DAP can be used up to 8 pounds per 1,000 gallons. Yeast hulls can be used up to 3 pounds per 1,000 gallons, whereas autolyzed yeast must be used with good manufacturing practices. So some things actually have a limit associated with them, and others do not have a limit. Likewise, there is another part of our regulations that we see the nutrients listed on, and that is the 27 CFR 24.250. And that the ingredients on there are not just nutrients, but nutrients are on there also were not part of our reciprocal trade agreement. So if they're on that list, it's fine to go to a worldwide trade group countries, but not others. So you must check with the country it's going to determine if this is an acceptable thing to use. So things like magnesium sulfate is on 24.250, and magnesium sulfate is essential to confer alcohol tolerance to the yeast. Okay, so just like the yeast doesn't know that it's in a Pinot Noir or a Chardonnay, it also doesn't know which part of the regs are it's in. It still needs it. So you've just got, that's why autolyzed yeast are such a wonderful thing in our industry, because they have all these vitamins and minerals in there naturally. So yes, you do have to be conscious with all ingredients you use.
Read the label, read the label.
Yes. Bookmark 24.250 and 246.
Okay. So great. If anyone have question, we can do like a quick question and answer. If anyone have any question, otherwise we are going to move forward. And thanks Nichola for spending time with us at Crush the Cellar today. Harvest again is in the corner. So if you need any nutrients, yeast, or anything else for your winemaking, remember that Crush the Cellar is the one stop for every winemaking needs. You can go on our website and get all your needs, or you can come to the store in Newburgh. So thank you very much, Nichola, for being with us today.
Oh, it's absolutely my pleasure, Sebastian. Happy to join you.
Yes, and everyone, good luck with harvest. Stay safe, work hard, and make good wine. I think that is the only recommendation we can give to everyone.
Thank you.
Thank you, Nichola. Oh, I see a Q&A quickly. Okay, where is my question?
Okay, so the question is, the last part of fermentation, oxygen is a limiting factor. Do you recommend adding oxygen at the end? So oxygen is a yeast nutrient. It's also utilized in a lot of other reactions, precursor for acetaldehyde, for color stabilization reactions, although the ethanol or acetal bridge isn't the major factor in color stabilization. But the yeast utilize oxygen to produce sterols And the yeast really need, and the sterols are incorporated into the plasma membrane. And the plasma membrane becomes really challenged by the time you're at the end of the yeast growth phase, because the yeast has had to divide 4 or 5 times and divide all of those essential compounds in their membrane. So the oxygen there is to try and regenerate some of the sterol. So at the onset of fermentation and at 1/3 of the way through from a yeast nutrition and yeast health standpoint. Does that address your question?
Yes, thank you. So just to remind everybody, then we are recording this webinar, and all the webinars are stored in the Crush to Seller website as well. So you can go back there and get and watch it again and again. We also have a resources page now. So we create like a fermentation tracking fermentation spreadsheet, I would say. Then you can download and use that for your Harvest 2020. So we try to bring some new tools for the winemaker. So feel free to go on the website and check that out. So thank you very much, Nichola. It seems that we are done with questions, and thank you and good luck with Harvest, and stay busy.
Thank you so very much.
Thank you, everyone.
Take care. Bye-bye.
Bye-bye.